Right, let's have a look at question 2, which is another pulley question. This time you've got your pulley on the end of a table. So in this question, the fact that object A is a little bit heavier than object B doesn't actually impact how the pulley moves. We know that gravity is going to pull this object down, which means that this object is going to move towards the right. So when I go to draw my diagram, I make sure that my double arrows, which represent my acceleration, move towards the right and down in this direction. The other things I've included here are the total weight of object B, which happens to be 4g. Again, remembering that g represents our gravity, which is 9.8. Here, if you don't want to include the weight of 5g, you don't have to. I did. The important thing to remember here is that even though this does have a weight pulling it down, it's also got that reactionary force of the table pushing up against the object, and those two forces are going to be equal and opposite, so they are actually going to cancel each other out. What you do need to remember though is that the mass will impact what happens here. So in part A, I'm asked to find the tension in the string before B hits the ground. So I'm going to start with my F equals ma, and I'm going to set that up for particle A, which is this one here. Really the only force that I'm interested in is the force of tension. And my mass is 5, so I just did T is equal to 5 times A. For particle B, it's a little bit more complicated. I've got my weight of 4g, or 4 times 9.8, and I've also got my tension acting in the opposite direction. Again, because the particle is moving down or accelerating downwards, that force there is bigger than that one, so it has to be 4g take away t and not the other way around. I've done that there. I then realized that in order to find my tension or my acceleration, I need to solve simultaneously. So I've labeled my equations 1 and 2, and I went ahead and substituted 1 into 2. Now, for this particular question, I probably shouldn't have done it this way, because when I substituted 1 into 2, I ended up finding my acceleration, not my tension, which is what they're asking for. It's not the end of the world, because I will need that value of A later on in part B. I just left it as that, and once I had solved for A, I went ahead and substituted that back into equation 1 to solve for T, which is approximately 21.8 newtons, or 196 over 9 newtons. Quick note about the acceleration here. I would highly recommend that you don't turn that into a decimal at this point, because you will have to round, and as we know, every single time we round an answer, it becomes less accurate. I am going to need that acceleration later on, so I've decided to leave it as a fraction. In part B, I'm asked to find the time taken by B to reach the ground. Now, there's a couple of things I need to keep in mind here. I know that B is 1.4 meters above the ground, which I've drawn down here. So I know that it's going to travel 1.5 meters before it hits the ground. I also know that the particles or the system is released from rest, which means that my initial velocity here is equal to 0. My displacement is 1.4 meters because that's how far it needs to travel to hit the ground. And my acceleration I happen to find in part A. You might not have found it in part A, which is fine. You would just go ahead and do what I did up here in part A, in your part B, to find your acceleration, which is approximately 196 over 45 meters per second squared. I'm trying to find my t, so again, I'm going to use my SUVAT formulae. In this case, I'm using s equals ut plus half at squared, which you can see here. I've substituted in all my values and found that t was roughly equal to 0.802 seconds. And that's it. That's the question done.